Welcome to Voices of Biocomplexity, conversations inspired by complexity. I'm Erin Raymond from the University of Virginia's Biocomplexity Institute, and in each conversation we explore how data, modeling, and interdisciplinary science help us understand the interconnected challenges shaping our world. Today we're talking about a problem that many people may never have heard of, but one with potentially enormous implications for agriculture and food systems, the New World screwworm. Joining me today are 4 team members from the Institute. Together, we'll explore what the screwworm is, why experts are concerned, how disruptions might ripple through food systems, and how modeling and simulation can help decision makers prepare for and respond to these kinds of threats. Thank you all for joining me today.
I'm Abhijin Adiga. I'm a research associate professor at the Biocomplexity Institute. I'm basically a computer scientist. I have been applying mathematical and AI methods to model biothreats to ag systems for nearly a decade now. So our ag systems are very complex. Diseases and pests have the opportunity to spread and impact us in different ways, often unforeseen. So to understand this process, we develop realistic representations of the ag system and model the spread, accounting for multiple pathways, including natural and human factors. So through these models, we try to come up with solutions that will make our ag systems more secure and resilient.
Hi, I'm Vidya Mani. I'm also a research associate professor at the Biocomplexity Institute. I mostly work around how we can make our global supply chains for basic food, electricity, energy, apparel, pharmaceuticals, resilient, secure, and sustainable. And food supply chains, surprisingly enough, you wouldn't think you would talk about this in the 21st century, but we still face shortages of food. Think back to the pandemic, when there was a lot of concern about not having enough supplies at the grocery store, whereas restaurants were all shut down. Meat packers were saying we can't get enough supply into the system, to when we had fertilizer shocks because of the Ukraine war, and now again with the US-Iran war, which affects all our feedstock. And then as you go through seasonal supplies of crops that are subject to both natural disasters and drought, how do we make them resilient? How do we figure out things within our supply chain that will help buffer against these disruptions? That's what I work on.
Samarth Swarup. I'm a research associate professor at the Biocomplexity Institute, and I work on AI and societal digital twins and large-scale agent-based simulations. And these are applied to many different problems, and that includes the spread of infectious diseases and parasites, but also the spread of technology and understanding human and environmental interactions and so forth.
My name is Christy Hall. I'm the Associate Director of Strategic Research Operations at the Biocomplexity Institute. What do we know about the screwworm situation and how it spreads?
So the screwworm is a parasitic fly. It lays eggs in open wounds of warm-blooded animals, which means that it has multiple hosts. These larvae then feed on the host's living tissue and cause severe damage and potentially even death if left untreated. So because it's a multi-host parasite, it can basically infect a wide range of animals, which includes both livestock as well as wildlife. So it makes it particularly challenging to control, as it can easily spread between species. Also, it has this ability to reproduce rapidly. Over around 20-day life cycle, a female can lay more than 3,000 eggs and can even fly over 100 miles in its lifespan. So these contribute to rapid infestation as well. Additionally, animals, especially livestock, are transported over long distances. Through movement of these infested animals or contaminated material, it can spread further.
Okay, that makes sense and is enlightening, actually. I'm learning a lot. And then why are we seeing this now? Why didn't we see this last summer or since the 1970s?
Yeah, so first of all, this is an interesting question, and people must be pondering about this since its reoccurrence in Mexico in the 2024-2025 period. But to give a history of this parasite, its native range included the US, especially the subtropical and tropical US, until it was eradicated somewhere around 1970s. In fact, it was officially eradicated or said to be eradicated in the 1980s. So what this means is there's always a constant threat of re-emergence. It's not surprising that it has come to parts of the US and it is able to thrive because it's already its native range, right? However, the recent outbreaks in 2026 are particularly concerning as it suggests a jump in the population because it's already been found in Mexico in the 2024-2025 period, as I mentioned earlier, but in the south of Mexico, and suddenly now it is in the US. So this jump is definitely concerning. And another point is that in 2016, there was an outbreak in the deer population in the Florida Keys as well. So it is not that this is one sudden event that has happened, but of course it is surprising nevertheless.
And given where we are today, how do we stop this? There's talk of using sterile flies. Does that help? Are there other things like aerosol sprays over farmlands? Just generally, how do we get this under control?
There is this technique called the sterile insect technique. It is the most effective method till date in controlling the screwworm populations. In fact, this was the main method that was used to eradicate it. Basically, it takes the advantage of the fact that the female mates only once in her lifetime. It carries the sperm throughout its life cycle and delivers thousands of eggs. This method involves breeding large number of male sterile flies, and these are released into the wild. They mate with wild females, but no offsprings are produced. So that is how you control the populations of screwworms that actually cause damage. So just to give you a sense, billions of sterile flies were released between 1962 and 1975 just to keep the perimeter secure. So there are lots of challenges in applying this method, even though it is effective, because you need to rear lots of flies and be very strategic about where you release them.
And how do you use your expertise in modeling to kind of help identify future scenarios?
So as I said before, models can inform both security and resilience planning for ag systems. We have built models to study multi-pathway spread of various invasive species in the last 10 years in the context of commodity crops. There are lots of similarities here. We basically represent the potential pathways, the various actors as a multi-layered network, and then simulate the spread of the pest or the disease across this network. So then we can use these simulations to inform the mechanisms of spread, assess risk, vulnerabilities, devise and evaluate intervention strategies. We have also built a digital twin of the contiguous US livestock system, and we have already applied it to study the spread of bird flu. So one can use such systems to even study screwworms effectively.
And the USDA, I think, already confirmed that it's moved from cattle to goats to dogs. So we know it can come from Mexico to the US. We know it can go from one state to another. We know it can cross species. But what happens as it begins to spread to other species?
The biggest problem is our concentrated and intensive production systems. So once it starts moving from one species to another, it can very easily get into large farms. And that's a cause, like a big concern, because these large farms will act as reservoirs, help multiply the screwworm population rapidly, and then there can be a severe outbreak or even an epidemic that concerns multiple hosts. Because as I said before, screwworm is a multi-host parasite anyway. Many warm-blooded animals are its potential hosts. So that's the biggest concern. The fact that we have multiple species in our ag system which are being intensely produced, it has lots of opportunities to spread and go out of control.
Thank you so much for your expertise. And given the threats from the screwworm situation, what does this mean for the cattle and beef supply, especially given the summer season?
All of us are looking forward to barbecuing over the July 4th weekend, towards a summer season with lots of travel, lots of eating out. The World Cup is coming. That's going to bring in a lot of people into the country, going out. And that particular movement puts a strain on both the restaurants and the food supply in general, but particularly on meat supply. Couple that with inflationary pressures that you're seeing right now, food prices are already ticking up 20 to 30% higher than what they would be at this time 2 years back. And the triple whammy is drought or natural hazards that have led to lower cattle herd in the sources of supply. Now, if you think of how beef production happens in the US, a lot of it is within the US, around 80 to 85% we source within the country. But it's not that you could grow today, unlike the screwworm scenario that Abhijan was talking about, where they can reproduce or do that in 20 days. It takes almost 2 years before you can get from the birth of a calf to getting it to the meat packer. And even within that, there are at least a couple of players. So, for example, going from cow to calf at the end of a year, most farmers would decide whether they want to take that cattle and put it back into breeding or some other use, or do they want to sell it forward into the supply chain such that it gets into the meat packing. From there, it is fed, the weight gains, and up between around 1,000 to 1,500 pounds is when it's ready for slaughter. And slaughterhouses or meat packers have these very processed equipment that they can only handle the supply or the cows coming in between a particular weight size, right? So drought, high prices, and a whole lot of demand means that for this particular summer, if the screwworm disease also impacts production, we are going to see extremely thin rows of steak, more probably of ground beef, more lean protein in the grocery shelves. And that's what our summer palette is going to look like.
Can the US source beef from other parts of the world or substitute with alternative meats?
And those are two very separate questions. Yes and no, right? Cattle is not exactly the easiest thing to transport over long distances across continents. These are not chips, these are not t-shirts. They take up a lot of space, they take up a lot of bulk. Most cattle transportation you would see would be within neighboring countries. So, for example, Australia would send its herd to Indonesia, right? Within Northern America, it would be Mexico, Canada, and the US. Yes, you could get, but you cannot import live cattle from Mexico, especially because of the screwworm outbreak that happened the last year or so. From Canada, Canada actually sources a lot of the cattle from Northern America. They've actually shifted from the southern borders to the Northern America to prevent this problem from happening. And if you look at weather patterns and summertime and holidays, they go in parallel across all three regions. So getting live cattle, especially at the point at which it's ready for the meat packer, is extremely tenuous. And you go through USDA regulations, you have to make sure that the quality is right, they're not infested with something else. What's more common is to get beef cuts that is post the meat packer stage, because by then they're being cut into slabs and slices that can be readily transported. And for that, we usually depend on Brazil, Argentina, and other places. But that's where it's more lean beef, less fatty content than what it is within the US. And that's the piece I meant by saying you'll have to look at more leaner options. In fact, the US actually exports a lot of fatty beef to Japan, South Korea, places like that. The place where cattle is gone determines a whole lot of what kind of beef you would see, and you'd see that pattern changing. So we could import from Brazil and Argentina, but it's going to be more of lean. That's going to be things that would go into your hamburger rather than that high price steak you would see on your plate. Right? So that's the point about trying to import from outside to manage the shortfall. Alternative meat option has been there since the last 7 to 8 years. It actually took a lot of investments, funding, about maybe the 2018, 2019 year time, mainly because beef itself or growing a cow takes a lot of natural resources, water, carbon monoxide emissions, things like that. So alternative meat, which you can get from proteins, that's what your alternative foods are. That's so you get hamburgers in your grocery aisle that are also non-beef, but alternative meat. They have come up as options, but they've not been able to scale. And the two main reasons are, as consumers, Americans really like their steaks. They really like their beef. And that taste is very hard to substitute. Second, most of the meat packing happens in like 4 or 5 companies: JBS, Tyson, National Beef, Cargill. And they have had years of experience to get quality control within their plants. Even their alternative offshoot plants have not been able to get across with good quality controls, especially on mold infestation and things like that. So yes, you have a complete alternative supply, but one, it does not taste as good, and two, you still may find other problems with quality, and it is nowhere near the scale to make up the short supply that we have right now with beef, which means we might look at more chicken, we might look at more poultry foods, things like that. And that's where the concern, once it starts going across species, would be even that substitution option might go away.
Right. That was going to be the next question. So what about the spillover of the screwworm to other meat supplies? And so those would be less available.
They would be less available. It also might mean there is both the science, and within supply chains, there is also a concern around what consumers perceive as the perceived impact. So the meat associations, every member in the supply chain, they've taken great pains to say that there is no human risk from contamination.
Mm-hmm.
But once it crosses species and it gets to things like milk supplies and things like that, the public worry around what is that potential contamination and what it would do could, one, reduce demand and put it over to other sources of supply. But even within that, you might see increases on poultry products, chicken, eggs, things like that. Again, for a consumer walking into the grocery store, they're seeing a 20% increase in price. That's going to now go up to 30, 35% because the supply chain itself is now pretty stressed out.
And this goes to something you mentioned when we first started. Why are we still talking about food supply problems in the 21st century?
Why, right? Especially when we are looking at building out AI models and artificial intelligence models that are so far down the curve. Why are we thinking of basic necessities like food and worried about it? A lot of work around understanding how resilient or how fragile our supply systems are came after the COVID pandemic. Yes, we used to have the avian flu, we had hurricanes, we had those kind of disasters and responses, but we never really saw how fragile our supply systems are. To one, yes, a lot of the food is grown nationally, so it's very subject to climate, natural disasters, including invasive species threat. And two, for critical inputs and components that come through the global supply system, like fertilizers, equipment, machinery, things like that. The other component that we typically miss, and that's come up quite a bit now, is the role of people, availability of workers to actually process material and food, whether it's crops, and in the case of meat packers, they've planned their schedules way ahead such that when you get a peak before any of the summer seasons, they would hire workers, temporary workers. And now, suddenly, if you're going to change things from one season to another season, you might get the supply, you might get the feedstock, but you may not get the workers. And at this point, all three are in a crunch mode. Inputs are at a crunch because of the geopolitics and the US-Iran war. The supply from within the country could be at a crunch. It is because of the drought, but could be further because of the infestation. And our current policies around hiring workers, and a lot of them tend to be on temporary visas, that's at a crunch. So you take all three together, it's not that the food is scarce, it's different points in the supply chain that are getting concentrated that's causing us to see the crunch at the end node in the demand side.
And is there anything else that we didn't cover so far that you'd like to add?
I would like to echo something that was said earlier in this call and the work that has been done in modeling these, how invasive species move, what can be the different interdiction efforts, you do not want it to happen actually in a county in Texas or New Mexico. I hear about it 5 days later in a news item and then think of what possible measures we could take. You want to be ahead of the curve and be able to model these things, especially given a long history of work on both invasive species and how do you model different spreads, infections, and mitigation efforts, to say what kind of possible pathways are out there and build buffers as well as separations between two systems that would help us contain if that pathway is taken, as well as figure out where and how we want to intervene instead of trying to figure it out once something happens. And I think we've had a lot of time to sit and analyze these events and build these measures out. We just have to apply those models and get ahead of the problem.
Samarth, how can Biocomplexity's work help plan for scenarios and responses in cases like the screwworm situation we have?
Yeah, that's a great question. What we really specialize in is making very detailed, very data-driven models. And these are models of human populations. These are models of agricultural systems, including livestock, and also various kinds of infrastructures like the transportation infrastructure and power and communication and so forth. And these systems are not isolated, right? They're all part of integrated system that we call society. And that's why we call our models societal digital twins. And when you have a situation like this, like the screwworm spread, right? And it's an ongoing process to respond and intervene effectively, you really need to represent the details of what is happening in the world. If you make simple stylized models, you cannot get practical interventions out of it. So if you want to know which farms are at most risk and which wildlife areas are at most risk and where is the best place to intervene, your models need to represent all of these things based on real data, right? And the real model of the interactions between these systems. So that is what we do, and that is what we've been doing for decades now. So the important thing here is having access to the data and having the methods in place to integrate data that are collected by different agencies and different systems, not necessarily meant to be integrated. But if you can find a way to integrate them, then they tell you a whole lot more about what is happening in the world. So that is the kind of work we do. And we build these digital twins so that we can then run simulations with them to look at, for example, where we need to build these buffers that Vidya just talked about, what might be the consequences of certain kinds of interventions, some of the things that Vijay talked about. And then if we have to choose optimally from limited resources, understanding how to deploy them, how do we go about doing that? So that optimization is also part of the question.
It's fantastic. And can you talk a little bit about past work where you've leveraged these scenarios and models for other infectious diseases?
Yes, so we've been working on infectious diseases in humans for some decades now. And our group has been involved in helping to respond to every major disease outbreak. So COVID, for example, we did a whole lot of work. And before that, there were several other smaller epidemics, thankfully. There was a Ebola epidemic in Northwest Africa, and now it's back in the Congo. And then before that, swine flu and SARS and many other things. And in all cases, we're tool builders. So we're not the ones who are the policymakers, nor are we the people on the ground. We are the ones who are doing the computational modeling, this detailed computational modeling that I described. And we're helping various response agencies at the state level, at the federal level, even at the international level, by providing them with useful information about the scenario and response options and optimal strategy.
And you touched on this a little bit already, but why is it important to model both the disease spread and consumer behavior or population movements? And sort of, can you give us a little bit of insight as to how you do that?
Yeah, so if you think about how the disease spreads, or really the coupling between what might be something happening in the environment, something happening in the human population, and something that's happening through our infrastructures, the thing that couples it all is human behavior. Right. So Abhijan mentioned, for example, that one of the main ways in which the screwworm is spreading is through transportation of livestock or of other kinds of animal products from farm to farm or from farm to processing plant and so forth. Right. That makes it travel a lot further than the screwworm fly can travel in its lifetime. So Abhijan mentioned a screwworm fly travels, maybe 10 to 12 miles in a day. It might travel 100 miles in its lifetime. But a truck carrying some infected livestock can travel many hundreds of miles in a day. So the surveillance systems we're putting in place, the disease surveillance systems, it really matters how we are intervening and trying to prevent the spread of these things. These are all policy, these are all behaviorally mediated processes, right? And so this is why it matters a lot for us to have good data in place, good data sensing mechanisms in place, to understand what are our own actions, human actions, that are making this problem better or worse, and what can we do to change those behaviors so that we can contain this process most effectively.
That was a great segue into the next question, which is always when things feel concerning, we all ask ourselves, what can we do? So what can farmers do? What can public health officials do? What can businesses do from your perspective in terms of getting us to a better place in this current screwworm situation?
Yeah, so the first thing is that consumers don't need to worry about this because it is not going to get into your food products. However, the screwworm can also infect humans or get into human tissue, and it can get in through even like a minor little scratch, right? Or a tick bite or something. It doesn't have to be a big open wound for it to attract these flies. So if you're out in nature, you have to be careful. You have to be watchful. You have to be aware of where there is a risk of the screwworm. Similarly, for farmers, I think they're well aware of this problem, and they're already taking measures to check for it in their livestock and to report it and to protect their livestock. So it is not something that we need to worry about as consumers. I think that as a sort of a policy response, it really depends on having good data in place. So like I said, good pest surveillance systems in place. And then having the computational capability to be able to take the data and then reason with it, to be able to project where it might go, or to plan out responses and figure out what would be the optimal way to respond.
And is there anything else that you would like to add that we didn't cover already?
I think that I just want to emphasize the importance of not just having data in place. In many cases, we find ourselves drowning in data, but it is important to have the computational modeling capability in place to be able to take the data and make sense of it, because that's what lies between getting the data in place and getting effective policy in place. You have to be able to reason with it well. And these models need to be of requisite complexity, meaning they have to, if you're representing a complex systems, you have to make complex models. So it's very important to have these methods and tools in place to be able to work with the data and the policy. So Christy, can you tell us about how people can engage with the Biocomplexity Institute, some of the ways in which we have developed partnerships, or some examples specific to invasive diseases?
As you've heard, the Biocomplexity Institute has a long history of working on really complex problems. Over the decades, we've engaged with multiple federal, state, and industry partners to solve the problems that they bring to us. An example of that is with the University of Washington, with USDA. We've had other projects looking at invasive plants internationally. And so really what we focus on is helping to solve those complex problems that our sponsors or partners have.
Can you tell people about how they can find us and talk to us and how they can leverage our expertise, particularly multidisciplinary teams, to model complex systems?
My first suggestion is to go to our website, which is biocomplexity.virginia.edu. And there's a contact email, biocomplexity.info@virginia.edu. We actually look at those emails. That doesn't go into a black hole or anything. We really take those in and get them to the right people within the Institute. Also on here, you will see individual researcher profiles, and we have our projects on the website, and we encourage you to reach out to anyone that you think would be a good fit or that you'd like to talk with. And I will say that the way we engage, it's a spectrum, right? So on one end, if you know exactly what kind of problem you want to solve and you have a specific funded research project in mind, yes, we can do that. On the other end of the spectrum, if you're not quite sure and you just want to get to know us a little bit and our work, want to participate in some industry insight panels, or learn and interact with our researchers and students, we have our Cascade Consortium, which we invite specifically industry partners to. But if that's something, you're not a company and you're still interested in something like that, definitely contact us. We're happy to talk through any other ways to get involved with us here and the exciting work at the Biocomplexity Institute.
Thank you for joining us for this conversation. I'm Erin Raymond, and this has been Voices of Biocomplexity, conversations inspired by complexity. If you enjoyed today's discussion, you can find more conversations, videos, and stories from the Biocomplexity Institute on our website, YouTube channel, and your favorite podcast platform. Until next time, stay curious, and thanks for listening.